All right, it's 11:05, and I think we're waiting for fair enough time. If people join the session later, we always have a recording of current sessions. So, and we will share this on our YouTube channel as well as emails with the reminders. Um, so let's get started. As I mentioned earlier, I would like to make one administrative announcement, actually two of them. First one is today is the last day to get the $500 discount for early bird registration for our comprehensive bootcamp, iOS native test automation with XUA test. For those people who are not familiar with XUA test, this is the native test automation framework, which is actually shipped with the Xcode. And we are teaching what we call more like a comprehensive program where you will experience what it's to be an IES software engineer in context of test automation. On our page, as you can see, we have a full schedule as well as the full course description, including the course syllabus, what we're going to do in each week during this bootcamp. So this is a great program for the manual testers who would like to proceed forward in a test automation field. It's also great for people who've been proficient in the web automation using Selenium WebDriver or Cypress and move into the mobile world. This bootcamp is definitely not for the beginners. It's for people who already been employed in quality field and would like to make a next step in their career. We usually position ourselves as the probably second tier or level 2 bootcamp, means that this is I would say the most advanced you can get out there. And after browsing through hundreds of different courses on Udemy and YouTube, as well as the LinkedIn Learning, we couldn't find anything as comprehensive as it is because we bring the real experience from real companies, real problems, and solutions from real projects and incorporating this bootcamp. So we cover topics that nobody wants to cover because of their complexity, but in the real world, you will encounter them. So again, $500, today is the last day. Starting tomorrow, it will be $1,999. We already have 8 people registered. So we literally have 2 more spots available for this early bird discount. After this, it will be just the regular price. It starts the June 16th. If you have any questions whatsoever about the program, how it's conducted, feel free to contact me directly in Slack. Also, whenever you get emails, you can reply to the emails that comes out of my email from this, online class. You can always find me, in Slack, like I mentioned earlier, and I can respond to your questions. Another announcement that so today Boris will still walk through you guys through the algorithms. Next week we're gonna go to more advanced topics, from real companies. And not the next week, but the following week, we're gonna dedicate the entire session for the interview process, because we talk about the algorithms, we talk about coding challenges, but we never talk about the what other aspects of the interview are very important, such as the resume, LinkedIn profile, such as how to behave in an interview, what questions you should ask, what question you should not ask. We have a lot of experience ourselves working through different interviews. Also, we have collected a lot of feedback from our current and our alumni students who brought it to us, like what they've been asked. And we incorporated in very comprehensive, documentation, which we'll share with all of you, which will most likely help you during tough times right now when you have to, compete with a lot of people. And obviously, we want all of you to be on top of that competition and get the employment. So again, not the next week, but the following week, we after Memorial Day weekend, we're going to cover that as well. Saying this, I would like to pass to the Boris. Boris, it's all yours right now. I'll stop sharing the screen.
Thanks, Igor. Let me share my screen now. Do you see my screen?
Yes, we do.
Cool, thanks. Great. So let's start from our homework. We're going to spend a lot of time today on this question. This problem is really famous and very popular on the real interviews. And this is number one problem on the lead code, means it's really popular. So problem is named toSum. Given an array of integers, return indexes of the two numbers such that they add up to a specific target. Great. So you may assume that each input will have exactly one solution and you may not use the same element twice. That's great. Now, let's start from our 8 golden rules. We remember that, right? And we are going to talk about 2 different approaches here. And that's the common approach when you start from one solution and then you understand that there is more efficient way to solve the problem and you switch. That's absolutely normal, and sometimes it's even better if you present 2 solutions. Cool. So let's go to our project. I'll create a new branch so you can easily find the solution in our Git repo after. Let's create the Java class toSum.
I will reemphasize 8 golden rules that Boris just mentioned and repost them in a Slack channel for those new folks who just joined our class and never heard of it, or because you might miss the first few sessions. So I'll share it in Slack channel.
Great, thanks, Igor. And I'll, as usually, write them right above the problem. Okay, so that's our 8 questions. We really recommend you to ask yourself whenever you're doing any coding challenge. Number 1, what is the input parameter? When you do the problems on the lead code, you usually have the template provided by lead code for you, right? This template has the input and output, but you, on the real interview, you will not have this template sometimes, right? You have the problem itself, so practice to understand what is the input and what is the output based on the problem description only. Okay, so we are given an array of integers and a specific target, because our goal is to find 2 numbers inside the array that will sum up into target. For example, if we are given with array 2, 7, 11, 15, the target is 9. We are looking for 2 different numbers inside the array that will sum up to 9, right? Obviously, in this particular example, we are looking for 2 and 7, because 2 plus 7 will give us exactly 9. And we can assume that each input would have exactly one solution, meaning if we found one solution, it is enough to say that we found the answer on the problem. And the result, so let's start from the input. The input is array of integers and the target. So I'll copy the function from the template. The return type is array of integers as well. Why? Because they are looking for, so we are looking for 2 numbers here, right? In our case, 2 and 7, that will sum up to 9. What is the way to return the answer? They are asking us to return the array of exactly 2 numbers inside. And those numbers will represent the indices of the numbers that sum up to target. So in our case, 2 and 7 are the numbers we are looking for. So the result is 0 and 1, the array of 0 and 1, because those are indexes of 2 and 7 in our input array, right? So the result is 0 and 1, because number with index 0 is 2, number with index 1 is 7, and 2 plus 7 gives us exactly 9. Hopefully it's clear. That's why the result type will be integer, will be the array of integers. But we know that there will be always exactly 2 numbers inside the array. Cool. Let's move on. So then what data structure methods associated with it will be used. That's a little bit harder, right? Not always you know exactly in advance what you're going to use. For example, let's assume we just got this problem on the interview and we do not really know right away how to solve this problem with the help of data structures. Let's say you think about this for like, I don't know, 5 minutes and you don't have any solution yet in your mind. That's a good way, that's a good time period to start thinking of brute force method. Almost every algorithm can be solved with the brute force. What does it mean? I'll show you today, and then we'll optimize a brute force solution with another one a little bit smarter. How to do that? So what is a brute force? Brute force is just trying every single possible combination. Let's say we have an array and we are looking for some specific sum of the elements. Obviously, the number one solution here, brute force, will be trying every single pair of those elements, and we're going to try to find the pair that gives us target in a sum. So just dump straightforward solution, but usually it works, right? Because you can try to pair every single element here. It is not that hard. You need 2 for loops here. And we're going to try every single number with every single other number. And some pair will give us result 9. That's exactly when we will say that's a pair we're looking for. So let's start from this solution. And on the real interview, again, if you do not know how to solve in a smarter way right away, it's absolutely fine to try just straightforward method. Okay, so I'll just name it first one, brute force. Let's create 2 for loops. One will run I from 0 to the end of the array, nums length, I++. And in the same way, simultaneously, I'm going to run the second loop with j. Both are going to be run on the same array. So I'll try to pair up every single possible combination of those numbers with these 2 loops. So I'll get basically num1 by array, nums from I, and I'll get num2 with nums from j. You can understand here that on the every iteration of the I, I'll run through all possible iterations of j. Meaning if I'll have the array, here, I will be 0, so the num1 will be 2, and while num1 is 2, num2 will run through every single number here. So there will be a pair 2, 2, 2, 7, 2, 11, 2, 15. Then I will be incremented, so the next set of pairs will be 7, 2, 7, 7, 7, 11, 7, 15. then 11, 2, 11, 7, 11, 11, 11, 15, and then 15, 2, 15, 7, 15, 11, and 15, 15. So I and J will run through every possible mutually, like every possible pair here. Great. Now, if num1 plus num2 will give me the target, this means I found the target, right? So I'll just return the array with I and J inside. Probably new. Sorry. No, sorry. Why it doesn't work? I want to create an array of I and J. That's strange. So I can declare the array obviously, but I need to immediately declare it with I and J here. So obviously it should work like that, I and J. It is int. Oh, of course, yeah, new int. Yeah, you're absolutely right. Thank you guys. Feel free to help me whenever I lose the syntax, since Java is not my primary language. Great, thanks. So yeah, I just returned the pair of ij. When we know by the description that we will have exactly one solution. So obviously there will be no situation when we will not find this solution, but for compiler, we need to provide some result, right? So new int, like 0, 0, whatever. We know that description guarantees us that we will not have this situation. So we can assume this works. Okay, there are multiple problems right now. Let's run a write-time unit tests, and then we'll fix those problems one by one. So let me create a unit test file, test some, to some tests. Great. So let me try to do that. Test to some brute force. To some. Great. So let's use this for now, 2, 7, 11, 15. Expected result will be new int with 0 and 1, right? Great. And we know the target is 9. So now let's run our actual result, which is to some brute force with array and target. Target to some brute force, int nums and target. And we are trying to pass their array and target. So what's the problem here? We are going to say that actual result will be an array. Absolutely right, yes. So the result type is obviously an array as well, right? And then we are going to assert that expected result equals actual result. Oops, wrong one. Just want to run it. Okay, test failed. Why it's failed? And obviously Java does not show us the real difference, but Yeah. Okay. Obviously, we can understand what's the problem here. And by the way, one more way to try is you can just try it in the lead code, right? You always can try to run your code here. And as I mentioned, there are multiple problems here too. 2, 7, 11, 15 with target 9. Actually, it should work with our solution. Why it doesn't? Let's try again. Oh, because I'm the assertion probably is wrong. I need to write assert array equals. This is important probably because I assume Java compared the memory. Java compared the arrays, not the value of arrays, but where they are stored. So memory addresses. Yeah, now it works. However, if I am going to try to run this test in a lead code with a submit, you'll see first problem. First problem is we'll get the wrong. Here is it, wrong answer. So 3 to 4, if I'm going to run the test like this, the values are 3, 2, and 4, 3, 2, and 4, and the target is 6. The expected result will be 1 and 2, because we know that by description, you may not use the same element twice. So 3 plus 3 does not count. We are looking for 2 plus 4, because 3 plus 3 is also 6, right? But we are looking for, here's it. So expected 1 and actual 0. Because our brute force just found the pair 3 with 3 and returned it. This does not work. We are going to add one more condition. We can say that I'm looking for sum, which is target, but also I'm looking for I does not equal J. So if I'm looking on the same element, let's say 3 and 3, then this I and J will be both 0. They'll be same. And those elements do not count. Let's try to submit now. Okay, accepted. Let's try to submit. Okay, we successfully submitted the problem, which is great. As I mentioned, can we start second loop from second position instead of 1? Yes, that's a good idea. We probably can start from 1, but I would, yeah, we definitely can safely do that, but it's still not enough. We will still have not efficient algorithm because we're going to talk about runtime now. If you are going to check out the details of our submission, which is successful, you will see that the average time of the submission is somewhere around, so the distribution is the majority runs within 35 milliseconds or something like that. And we took 178 milliseconds to do it. So our solution is extremely slow. Why? So what is the runtime complexity here? That's a question to you guys. What's runtime complexity here? Yeah, so the runtime complexity is big O from n squared. Why? Because for every single I, we're going through every single j, meaning total time is n time n. N time n means the total runtime complexity is big O from n squared. What's the memory complexity here? Great. Big O from 1, constant. We do not use any additional memory. Those variables do not count. They're single variables only. Perfect. Now, we know about the time and we know about the memory. Let's try to increase, like, optimize our runtime complexity by making our memory complexity a little bit weaker. So that's the common approach. We can sacrifice a little of memory if this will give us a great time optimization. So we're going to use the data structure, which will obviously give us more memory used. However, it will allow us to do it much faster. So same problem, different solution. And this is like, this solution is famous. However, it's really hard to guess how to solve this problem if you never solved it before, to be honest. It's really hard to understand that we need to use this specific data structure in this way, and this will give us optimal solution. However, I'll show you how to do that. And then if you see this problem in the interview, you know exactly how to work with it. So our secret weapon will be the hash map. The hash map that we will fill out in a little bit unusual way. So let me just create the map, the hash map. So obviously it will be integer. Sorry, map equals new hash map. Great. So I'll create the hash map. As you remember, hash map is the data structure that allows us to store the pairs of elements. Let's say if I declared integer, I'll be able to store the int only pairs. Now I'll go through every single element. I'll go through every single element and I will fill out the hash map. However, usually we can think of, if we have array and we're going to create the hash map from array, usually we can think of like creating key as a, like index as a key and value as the value. In our case, we're going to do a little trick. We're going to store the pair where the key is actual value from array and the value is an actual index from array. So every time I'll put in my hash map, the key will be nums from E, and the value associated with this key, sorry. So the key will be nums from E, and the value will be I itself. So a little bit vice versa, right? Basically, we will store the pair 2, 0, 7, 1, 11 to 15, 3. So the element and the index as at the value of this key. Does it make sense, guys? Is it clear? I'll show you why are we going to do that a little bit later. Yeah, but it's important to understand this small trick. It will help us in 2 minutes. Cool. Great. Now, we have this hash map. So if we know what element are we looking for, it will take us a constant time to find the index of this element, right? Because we know that if we have a key, we'll find out the value within the constant time, which makes this data structure so great. So now let's create a second for loop for same for loop from 0 to the end, and knowing the exact element one by one, right? We'll see 2, 7, 11, 15 here. Knowing the exact element, let's say 2, we can easily find a complement of this number. What is a complement? If we have 2 and we know the target that we're looking for, then complement will be the second number that we would like to have in order to get the target as a sum. So if we have 2, the complement will be 7, because if we would have a 7 in our array, we know that those two elements will give us a target 9. For a 7, the complement will be 2, because we know if we have 7, we would like to have a 2 in the array, because their sum will be 9. What is a complement of 11, for example? That's a question to you. What is a complement of 11? -2, right? We would like to have -2 in our array because this sum of 2 elements will give us 9. What is a complement of 15? -6, right? Because 15 plus -6 will give us 9. Great. So we are given with this number, right? We have int num1, which is nums from I. Now, how to find the complement of num1? Exactly. We have a target and we have one number. Obviously, we can find the complement by subtracting the num1 from target. We have a num1, we have a complement. And now we can see that we have this map where we can instantly find the index of any number. So it's not a problem for us to check, do we have this complement in the hash map that we created for us? So if the map contains key, the complement, if there is a complement there, then we can say that num2 will be map get complement. And now we can return new int, and the two indexes will be I and, sorry, this is actually not num2, right? This is index of num2. Yes. So if we are going to get it from Hashmap, it will be the index of num2. So it will be I and index of num2. Obviously, let's remember that we are not looking for same numbers. Same as here, we did the check that I does not equal j. Same here. We are going to look only for those that I does not equal and I does not equal to map get complement. If we don't find that, let's return same zeros. Cool. Let's do same two tests, but using the new solution instead of brute force. So let's remove brute force here. I'll remove brute force here. I'll remove brute force here, and I'll remove brute force here. Let's run all four tests. Sorry. Let's run all four tests, and all four tests passed. So let's try to lead code our solution. Submit. Now we have 8 milliseconds. If you remember, we had 125 in the last time. So they have pretty big data for tests, and this efficiency is not something like, not the theory only. You can see the real numbers changed by optimizing your solution. Questions? Obviously, the good question is, what's our new complexity, right? What is time complexity? And what is memory? Yes, we can do it in one for loop. It is possible. A little bit harder though. Try to do it at home. And feel free to share the solution in the channel. It is possible to do it through one for loop, but it will not give you the better complexity. That's the truth. So 2 for loops or 1 for loop doesn't affect the overall time complexity. So this is the best complexity you can do. You can still improve it a little bit with 1 for loop instead of 2, but you get the same time complexity. What is time complexity here? Time now is big O from n, which is extremely better than n squared complexity we had before. But what is the memory complexity now? The memory complexity now is big O from n as well. So you see, we had on square time constant memory, and we were managed to do big O, like linear time and linear memory instead. So we sacrificed a little bit memory to achieve better complexity. Cool. Any other questions? And let's move on to the next question. No question. Cool. Let's go forward. So this is done. The next one is move zeros. So move zeros is one of the most popular question on Facebook specific interviews. Facebook interviewers love this question. I do not know why. It's really interesting, but it is so popular for them to ask this specific interview question on their interviews. So the problem statement is, you remember we did once the array of, we started, our first question was our first question was how do so one, it was an array of ones and zeros. This is a little bit more complicated version of the same thing. So basically you have an input of any numbers and you're asked to move all zeros to the end. And yes, not only Facebook, Apple solves this problem too. That's true. And you can see somebody, Sergey, got it once on Google. Thanks, Sergio. Yeah, so people really solve this question lots of times. That's why we have to show this problem in this class. So let's create move zeros. What is our input? It is the array, right? What is our output? We don't have any output, because you can see here that you must do this in place without making a copy of the array. What does it mean? Making it in place means you should do it with big O from 1 memory complexity. Basically constant memory complexity. You are not allowed to allocate any other arrays. And obviously minimize the total number of operations, but that's valid for any algorithm out there. Let's try to brainstorm a little bit. We have the array. And we would like to get this array instead. 2 pointers and 0 counter. Right, that's what we need. But this this is not really common 2 pointers. So basically we are going to override, the 1 pointer will be override the bool pointer, right? Okay, let's try to solve it. So the idea is we are going to have 2 pointers. That's true. So 2 pointers is a very popular approach in algorithms. We are going to have 1 pointer that just runs through our array usually, like normally, but we are going to have second pointer that will be behind the first pointer, that will be override our elements based on what the second pointer will see. Yes, 1 read pointer, 1 write pointer. Yeah. Again, popular approach, applicable to many of algorithms. So let's create the regular one first. So int I equals 0, I less than nums length, I plus plus, regular stuff. Now, the second pointer will basically show us so it will find zeros. It will find, no, sorry. So basically the idea is to find all not 0 elements, and the second pointer will write them out. So the first pointer will skip zeros, and the second pointer will write not 0 elements in a row. With this approach, in the end, we're going to have all non-zeros in the first place. this will give us an ability to just follow up with the zeros after. So basically, the normal pointer will just go here and will indicate whenever it will see not a zero, the real element. At this time, we're going to override the element that the second pointer points to with the element the first pointer found. So let's do, I love the idea with read pointer and write pointer. I'll use that. So we're going to have, this will be our read pointer. I like the name. I'll use this. Thank you. And write pointer, which is 0 by default. So a read pointer goes through every single element and it just keeps zeros. But once it finds the not zero element, so nums from read pointer is not zero. So we skip 0, we are not interested in it. But once we see 1, we know that write pointer should override the element with it. So basically we're going to say nums from write pointer equals nums from read pointer. So I'm going to override the 0 with 1. And increment write pointer. So this will give us one, 0, 3, 12. Then we go with read pointer further. Read pointer points to 0. We do not react. We go further. Any significant advantage of using nums write pointer? Obviously, it's a little bit more advanced. It's better, right? So it's same thing. Make sure you do not do ++ write pointer. This is a different thing. So we are interested in do nums write pointer ++. Means it will use write pointer and then it will increment it. We can do that, right? That's just a sugar syntax. So we skip 0. Read pointer goes further. We see 3. 3 is not 0. So we are going to override this element with 3. So we're going to have 1, 3, 0, 3, 12. We go further, we see 12. 12 is not 0. So we're going to override this 0 with 1, 3, 12, 3, 12. That's our result. Now, we know exactly that everything, once we've done with read pointer, everything that is beyond the write pointer should be 0. Because if we are going to move those zeros to the end, those two things should be 0, like that. Not a problem. We can create a second for loop. Let's just use I here. I nums length, and we would like to start not from 0. We would like to start here from where did we stop last time, right? We started somewhere on write pointer. And at this point, we are going just to nullify this element. So those two was should be zeros. That's it. That's it. I'll create, oh, sorry, it should be here in Algo. And in test, we're going to create move zeros test. Questions so far? So let's use this as an example. So basically, our expected result will be 1, 3, 12, 0, 0. And there will be no actual results here, right? We're just going to apply our move zeros function on our array, and the assertion will be basically assert that our new array will be equal to the expected result, something like this, right? Can we do it in Swift? Yes, of course you can do it, and feel free to share your solution in the Slack channel. I love Swift, you know this, but this is Java class, so obviously we show Java code. And we pass the test. So let's try to run the same solution in LeetCode. So move zeros, I'll just copy this. You see, very elegant solution, very small, but so powerful. Is there any more optimal way? Hard to imagine there could be. Yeah, I don't think you can do it more optimal. This is obviously big O for man with constant time, right? And you can see that zero milliseconds, yes. Faster than 100%. Congratulations, guys. We did the best solution on the LeetCode. Yeah, so time, let's write it down. Time is big O from n, because we have just 2 independent for loops here, and memory is constant, which is what they asked for, right? Can we use pop and add methods? Good idea, good question. I don't think you can pop from the array, from the middle of array. I don't think you can pop from the middle of array, right? You can append to the end of array, but you can't pop from the middle, so it will be hard to do it here. Yeah, that's basically it. Let me give you a homework. So homework will be a little bit easier probably than last time. So, but it's really important question, one of the fundamental question. So you probably know what is prime number, right? So prime number, this is math 5th grade probably. A prime number is a natural number greater than 1 that is not a product of 2 smaller natural numbers. Means if you have 15, you can create a product. You can find 2 smaller natural numbers that will give you a product of 15. For example, 3 times 5, right? Will give you 15. But if you have, let's say, 17, you are not able to find any 2 numbers that will give you a product of 17. So this is a prime number. Prime numbers are very heavily used in cryptography, for example, because there is no efficient algorithm to find them. And your homework is to write a function that takes an n and finds all prime numbers that are smaller than this n. I don't think there is a LeetCode task, to be honest, but I think this is important question, so we should go over it. Feel free to, I will take a look as well, but I don't think they have this problem. Okay, thank you for attention. You're awesome. Feel free to ping us, ask any questions. Make sure you are subscribed to our YouTube channel. And friendly reminder that we have last day of early bird registration for iOS native bootcamp. Thank you. See you next week.